Alright, so we were working on solving these homogeneous linear equations with constant coefficients. And we do that by finding the auxiliary equation, and then depending on whether we have a repeated solution, two distinct solutions, or a imaginary solution, we write the answer accordingly. Here's another example. This is an initial value problem. All right. We're given y of 0 equals -1 and y prime of 0 equals 2. Alright, so we need to write down the auxiliary equation. It's 4m squared plus 4m plus 17 equals 0. Before you try to factor, you may want to see what b squared minus 4ac is equal to. That tells you what type of solutions you're going to have. So it's going to be 16 minus 4 times 4 times 17. That's going to be 16 minus a big number, so that's less than 0. So that means you're going to have imaginary solutions or complex conjugate solutions. So we have to solve for x. So that's going to be -4 plus or minus the square root of b squared is 16 minus 4 times 4 times 17, all divided by 2 times 4. So that's -4 plus or minus the square root of, let's see, -256 all over 8. So that's -4 plus or minus, I think the square root of 256 is a whole number. Is that 16? Yep. So that's plus or minus 16i all over 8. So that is, use termwise division, -4 over 8 plus or minus 16i over 8, -1/2 plus or minus 2i. Alright, so alpha is equal to -1/2 and beta is equal to 2. Alright, so the equation we're going to use is e to the negative x over 2, because that's negative alpha x, times c sub 1 cosine of 2x plus c sub 2 sine of 2x. Alright, now we're going to solve for c. So we're going to have y, which we have, our solution, and we're going to have the derivative y prime. Alright, so y prime, I'm just going to use the product rule. So it's going to be this term times the derivative of, be -2 c sub 1 sine 2x plus 2 c sub 2 cosine 2x. So that's the first times the derivative of the second plus the second times the derivative of the first. The derivative of the first term is negative 1/2 e to the negative x over 2. Alright, so I have my first two derivatives. So now I can use my initial values there. Y of 0 is negative 1 and y prime of 0 is 2. I'm going to plug that in the top equation up here. So when you plug in a 0, you get out a negative 1. So I'm going to have negative 1 equals e to the 0 times c sub 1 cosine of 0 plus c sub 2 sine of 0. So that's negative 1 equals, that's 1 times c sub 1 cosine of 0. That's 0, that's 1. That's going to be 1. So c sub 1 is equal to negative 1. Alright. I thought we were going to have to do a system of equations, but things canceled out nicely. The other initial value is y prime of 0 equals 2. So I'm going to plug that in for y prime. So 2 equals e to the 0 times negative 2 c sub 1 sine of 0 plus 2 c sub 2 cosine of 0 plus, actually, since there's a negative 1/2 e to the negative x over 2, it's going to be minus 1/2 e to the 0 times c sub 1 cosine of 0 plus c sub 2 sine of 0. So all the sine of zeros go away. E to the 0 is equal to 1. So I have 2 equals, that's going to be 2 c sub 2, because that's 1. And then that's 1. So you got to multiply it times negative 1/2. So it's going to be minus 1/2 c sub 1. Scroll up. Okay, I'm about to come back down to that where I'm solving. Right there. Alright. So c sub 2, let's see, I can plug in c sub 1, that's going to be a negative 1. Plug in there. So it's 2 equals 2 c sub 2 plus 1/2. So that's going to be 4/2. So I have 3/2 equals 2 c sub 2. Divide both sides by 2. So c sub 2 equals 3/4. Alright, so the solution to that initial value problem is y equals e to the negative x over 2 times, so we plug in our c sub 1 and plug in our c sub 2. So that's going to be negative 1 cosine 2x plus 3/4 sine 2x. That's the solution. Alright, if we have a third order differential equation, these are all second order that we've been working with. But if we want to solve a third order differential equation, then what would our auxiliary equation be? The y triple prime there gives me m cubed, and then the y double prime gives me m squared. I don't have a y prime, and then I have minus 4 because of the minus 4y equals 0. So we have to figure out a way to factor that. The only way that I know how to factor that is to guess a factor, see if it is a factor, and then if it is, use long division, divide that out, and then hope what the quadratic that I get as a result is factorable. So you have to, try a couple of low numbers. Like 0 won't work because if I plugged in a 0, I have negative 4 equals 0. 1 will work though, right? If I plug in a 1, m equals 1, that would be 1 cubed plus 3 times 1 squared minus 4. So if I plugged in a 1, then I would get 4 minus 4, and that is equal to 0. So what that tells you is if we've guessed an answer of 1, then m minus 1 has to be a factor of that polynomial. Because if you set that equal to 0, you get m equals 1. So when you guess a factor, then you can divide that into the polynomial. And I'm going to put plus 0m there since I don't have an m term, minus 4. So this is going to be m squared. Then I'd have m cubed minus m squared. Then I have to subtract both of those. So minus plus, that cancels out. I have 4m squared. Then m times, let's see, a positive 4m would give me 4m squared, and that gives me minus 4m. I have to bring this term down. That's plus 0m. Then I have to subtract both of these. So that's 4m. Then m times what is 4m? Well, that's 4. Hopefully I'm going to have no remainder. If I don't have a remainder, that means that everything's working as planned, and I might be able to factor this next thing. Maybe or maybe not. You really don't know. So that's 4m, and then minus 4. Then bring down this last number. It's minus 4. Subtract, subtract. So they do cancel out. I get 0. 0 is my remainder. So I know that m cubed plus 3m squared minus 4 is the same thing as m minus 1 times m squared plus 4m plus 4. Now m squared plus 4m plus 4, how does that factor? Does it factor? m plus 2 plus 2, right? Gives you a positive 4m in the middle and gives you a positive 4 when you multiply the 2's together. Alright, so what are our solutions then? We have m minus 1 equals 0, and then a repeated solution of m plus 2 equals 0. So m equals 1, m equals negative 2, m equals negative 2. So how would I write? We want to use the same logic as we did when we wrote a solution with repeated answers with a second order. We have y equals c sub 1, and since this is m equals 1, that's going to be e to the 1x plus c sub 2 e to the negative 2x. And then the repeated answer I have to put plus c sub 3 x e to the negative 2x. If there would have been another one of those, I would put plus c sub 4 x squared e to the negative 2x. Just keep putting an x there with each additional time that the answer is repeated. Alright, let's see if I can find you one like that to practice on. This one don't look too bad. Y triple prime minus 4, y double prime minus 5, y prime equals 0. So write the auxiliary equation and then see if you can factor it and find the roots of the equation. Alright, so you can check your factoring. I just factored an m out, and then the quadratic factored easily. So I got 3 answers. One of those was m equals 0 though. So that makes that term c sub 1 e to the 0 or just c sub 1. Any questions on that problem? Alright, now to have a little fun. 4.4, indeterminate coefficients, the superposition approach.
Can you write that down?
I am. Alright, so if we have a non-homogeneous linear differential equation. Then we have to do two things. We have to find y sub c, which is the complementary function, or I call it the complementary solution. And we must find y sub p. And y sub p is any particular solution of the non-homogeneous differential equation. And then y, our solution, will equal y sub c plus y sub p. Now the complementary solution, that is the homogeneous solution. So if the differential equation was to be equal to 0, like we did in the previous section, we find those answers. Then we have to figure out a way to find the particular solution of the non-homogeneous differential equation, and the solution will be the sum of those two solutions. Okay? So that's what we're going to do. Now, to find our y sub p, the particular solution, it's going to depend on what the right side of the differential equation looks like as to how we proceed. There is a table in your book. This is the table in your book. This table tells us the basic form of y sub p if we have the differential equation set to any constant, if we have it set to a linear equation, a quadratic equation, a cubic equation, and then from those you can figure out what you would do. You can just follow the pattern if you have a higher order polynomial. If it's set equal to sine of, I know this is a particular example, but sine of 4x would be a cosine 4x plus b sine 4x. And same with cosine, use the same particular solution. If we have an exponential, it's a e to the 5x. Then if we have a product of these, it shows you how to set those up as well. Okay? And this isn't the answer, this is just the general form that we have to use to get the answer. All right. So let's look at a problem. So let's say I wanted to solve y double prime plus 4y prime minus 2y equals 2x squared minus 3x plus 6. All right, the first thing that we want to do is we want to write down the auxiliary equation and solve it just like we did in the previous lesson. So the auxiliary equation is m squared plus 4m minus 2 equals 0. Now that is not going to factor. So that means the answer is either two distinct solutions that are real numbers, or it's going to be complex conjugate solutions. So we need to work it out with the quadratic formula either way. So it's going to be negative 4 plus or minus the square root of 16 minus 4 times 1 times negative 2 all over 2 times 1. So that's negative 4 plus or minus the square root. Let's see what that's going to be. That's going to be 20. Well, 16 plus 8. So that's going to be 24. So it's not a complex conjugate solution. It's just going to be two real solutions that aren't real pretty. They're not integers like would get with a lot of problems. Now I would simplify the square root of 24. That's square root of 4 times square root of 6. So it's negative 4 plus or minus square root of 4 times square root of 6 is 2 square roots of 6 all over 2. And then that simplifies to 2 plus or minus the square root of 6. So that is two solutions, though. Remember, that is 2 plus the square root of 6.
Wait, I thought it was the 2's would cancel out.
Yeah,
Before.
that should be a negative, right? Or should it?
Would the 2's cancel out and be 4 versus?
Like this?
Or
Math don't work like that. So that's negative 2 plus the square root of 6, and that is negative 2 minus the square root of 6. So the complementary solution y sub c is equal to c sub 1 times e to the negative 2 plus the square root of 6x plus c sub 2 e to the negative 2 minus the square root of 6 times x. So that's our complementary solution. That's the same type of solution that we would have gotten if we were just working a homogeneous linear differential equation with constant coefficients. The difference in this problem is that it's non-homogeneous. So we have to find the answer that we would if it was homogeneous, and now we have to figure out the answer, the particular answer, when it's equal to this here, which happens to be a quadratic. So our g of x, remember g of x from the general way to write a differential equation is what's on the right side. Our g of x is equal to 2x squared minus 3x plus 6. So what we want to do is, or one thing we can do is look at that table and see what we do for a quadratic. For a quadratic, y sub p is going to be ax squared plus bx plus c. Okay? So y sub p is equal to ax squared plus bx plus c. Alright, now we are going to see how many derivatives we have in our differential equation. We have the first derivative and we have the second derivative. So what we need to do to figure out this particular solution is find y sub p prime and y sub p double prime, and then plug them into the differential equation. So y sub p prime is going to be equal to 2ax plus b, and then the derivative of c is 0, and then y sub p double prime is going to be equal to 2a, and then the derivative of b is equal to 0. So we're going to take these and we are going to plug them into our differential equation. So all of this I'm going to put in right here. All of this I'm going to put in right here. And you guessed it, all of this I'm going to put it in right here. Alright. Alright, so when I substitute that in, I will have, I'm going to plug in the 2a first. So 2a, then I'm going to have plus 4 times y sub p prime. That's 2ax plus b. And then we'll have negative 2 times y sub p. That's ax squared plus bx plus c. And then all of that is going to be equal to the right side of my differential equation, 2x squared minus 3x plus 6. So now I need to distribute. Alright, so I'm going to have 2a plus 8ax plus 4b minus 2ax squared minus 2bx minus 2c equals 2x squared minus 3x plus 6. Alright, now I want to group like terms. So you see I have some constant terms. I have a 2a, a 4b, and a negative 2c. So 2a plus 4b minus 2c has to be equal to the constant on the right side of the equation, 6. Alright, now look at your x terms. That's this term and this term. You have a 8a and a negative 2b. So 8a minus 2b has to be equal to the coefficient in front of x and on the right side of the differential equation, which is negative 3. And then you have one x squared term, negative 2ax squared. So negative 2a has to be equal to the coefficient of the x squared term on the right side of the differential equation, which happens to be 2. What does this remind you of? Kind of reminds you of partial fractions, because you don't have to set up the partial fractions, but the whole coefficient thing that we have to figure out is the same as partial fractions. Then we have this little system of equations. It appears that you can solve for a first, then you can solve for b, then you can solve for c, just going backwards. So if we divide both sides by negative 2, we get a equals negative 1. Then we plug that into the second equation, and I have a times negative 1 minus 2, b equals negative 3. Alright, so if I move this 8 over, this negative 8 over, you have to add 8 to both sides. Then you'll have negative 2b equals 5. So b is equal to negative 5 halves. So we have a equals negative 1, b equals negative 5 halves. Now we can take this equation, the one with 3 variables, we can plug in a, negative 1. We can plug in b, that's plus 4 times negative 5 halves. And we can now solve for c. So it's negative 2. That's going to be minus 10 minus 2c equals 6. So negative 12 minus 2c equals 6. So negative 2c equals 18. If you move the 12 over. So c equals negative 9. So we've solved for A, B, and C. And y sub p is now equal to, remember the general form y sub p that we had? It was right here, ax squared plus bx plus c. We plug in our a, b, and c. And so we'll have negative x squared. Then we'll have minus 5/2 x. And then our c is minus 9. Alright, so what we can say is, so the general solution is y equals y sub c plus y sub p equals c sub 1 e to the, we had negative 2 minus the square root of 6x plus c sub 2 e to the negative 2 plus the square root of 6 times x and then we have to put in our y sub p, so minus x squared minus 5/2 x minus 9. So that is our general solution. All right. So just a quick review of what we did. So if we solve a non-homogeneous differential equation with constant coefficients, undetermined constant coefficients, we need to figure out the auxiliary equation and figure out our complementary solutions. Then we have to figure out a particular solution, and we set that up by whatever form the right side of the differential equation is in, and we can use our table to help us do that. Alright. Then we take as many derivatives as we need to, and we plug that back into the original differential equation and set it equal to the right side of the differential equation. You come up with a system of equations and solve for your undetermined coefficients, and then your general solution is equal to y sub c plus y sub p, that particular solution that you found. Here's another example. Let's say I had y double prime minus y prime plus y equals 2 times the sine of 3x. And these examples are in the book. I'm just working through them because sometimes they don't explain the steps. And we can work a few more from the end of the section when we get there. So this auxiliary equation is m squared minus m plus 1 equals 0. So will that factor? Don't think so. So that's negative b, so the negative of negative 1 plus or minus the square root of b squared is 1 minus 4 times 1 times 1 all over 2 times 1. So that's going to be 1 plus or minus, what's that going to be? 1 minus 4 is the square root of negative 3 all over 2. So that's, when you have a negative, you can put an I on the outside, so that's going to be 1/2 plus or minus square root of 3 over 2 I. Or sometimes you may see the I written in the front times the square root of 3 over 2. But this is our alpha and this is our beta. So the complementary solution is going to be that's c sub 1, no, not yet. That's e to the alpha x, so what is that? X over 2. Sorry, I was looking at something. Times c sub 1 cosine of beta x, so square root of 3 over 2x, plus c sub 2 sine of beta x, square root of 3 over 2x. So that is the complementary solution. Now, to figure out the particular solution, we have to look at the right side of our differential equation, and we have to look at the table and see what do we do when we have a trig function, or a sine function there. And the table tells us that if we have a sine or a cosine function, you have to put a cosine of whatever the u is equal to, plus b times sine of whatever the u is equal to. In this case, our u is equal to 3x. So y sub p is going to be equal to a cosine of 3x plus b sine of 3x. Alright, so y sub p prime is equal to, so we need to find y sub p prime for this term and y sub p double prime for this term. So y sub p prime is going to be negative 3a sine 3x, and then the next term is going to be plus 3b cosine 3x, and then y sub p double prime is going to be equal to negative 9a cosine 3x minus 9b sine 3x. So now I need to plug those into the left side of my differential equation for the different order of derivatives that I have. So that's going to be negative 9a cosine of 3x minus 9b sine of 3x. Then I have minus, so I'm going to have to subtract my entire y sub p prime. So that's going to make that, if I subtract both of those terms, that's going to be plus 3a sine 3x minus 3b cosine 3x. And then I just have plus y. So it's just plus y sub p. So plus a cosine 3x plus b sine 3x, and I've run out of room there, so maybe I'll just say, I might have to write smaller. See, it was just plus y sub p, so plus a cosine 3x plus b sine 3x. And then all of that is equal to the right side of my differential equation, which is 2 sine of 3x. Alright, so I need to group the like terms. So I have a cosine, and a cosine. I have three. Are any of those terms that I could put together? This one right here and this one right here you can put together, right? So that would be negative 8a cosine 3x. And then I'm going to write this one after it, minus 3b cosine 3x. Alright, now let's look at the sine terms and see if we can put any of those together. I think the same thing happens. This, so this one here and this one here are like terms. And then this is just another sine term. So that's going to be minus 8b sine 3x plus 3a sine 3x equals 2 sine 3x. So what I have here is negative 8a minus 3b times cosine 3x plus negative 8b plus 3a times sine 3x equals 2 times sine 3x. So I don't have a coefficient on the right side for cosine. So that means negative 8a minus 3b has to be equal to 0. And then I do have a coefficient for sine. So negative 8b plus 3a has to be equal to 2. So now I have two equations and two unknowns. If I had to guess, I'm going to get some crazy fractions out here. I'm going to rearrange the terms so that they are in the same order. And now to solve this, I'm going to have to multiply this equation by something that would make the a negative 3. So how am I going to do that? Well, I could multiply this equation by 3 and this equation by 8. That'd probably be the easiest way if you don't want to deal with the fractions to begin with. Multiply this one by 3, multiply this one by 8, and so that would be negative 24a minus 9b equals 0, and 24a minus 64b equals 16. So then if I added the two equations together, I get negative 73b equals 16. So that means that b is going to be equal to negative 16 over 73. Alright, so now I can solve for a by plugging b into any equation. I'm going to say negative 8 times negative 16 over 73 plus 3a equals 2. Even though that's not the easiest one to plug it into, why not? Let's see if I can make a mistake. Alright, so that'll be negative or positive 128 over 73 plus 3a equals 2. So I want to subtract negative I want to subtract 128 over 73 from both sides. If I get a common denominator of 73, then that is 146 over 73. So that gives me 3a equals 18 over 73. And then I divide both sides by 3, which is the same as multiplying by 1/3. So that's going to be a equals 6 over 73. So I've solved for a and b. So now that means our particular solution, y sub p, is equal to a, which is 6 over 73 cosine of 3x, and then plus b, and b happens to be negative, so that's going to be minus 16 over 73 sine 3x. So the general solution is y equals y sub c plus y sub p, or what did we get for y sub c? That's e to the x over 2 times c sub 1 cosine of square root of 3 over 2x plus c sub 2 sine of square root of 3 over 2x, and then cut that off there, plus 6 over 73 cosine 3x minus 16 over 73 sine 3x. Alright, let me see if I can find us, I'm not going to say an easy one, because these are definitely not like easy. I mean, they just take a lot of work. But let me see if I can find one that won't take too long, that maybe you can practice on before we work any hard ones. Alright, so this one shouldn't take very long. This is on page 147. Y double prime plus y prime minus 6y equals 2x. Alright, so what did you get for the complementary solution? What were your two, what was m equal to? Okay. You got m equals -3 and m equals 2. So that makes your complementary solution equal to c sub 1 e to the -3x plus c sub 2 e to the 2x. And it doesn't matter if you don't have them in that order, you can have them in the other order as well. Alright, so now we need to figure out our child particular solution, y sub p. And so how do we need to set up that? According to this little table here, the linear part, this number 2 there, ax plus b. So we have a x to the first, so that's why we have to use the linear one. Ax plus b. So find the derivative of that, and then the derivative of that, and plug it into the differential equation. Alright, so what's y sub p prime? A, y sub p double prime, 0. So if I plug this into my differential equation for the second derivative, first derivative, and then the solution of the 0th derivative, then that would be 0 plus a, then I have to say -6 times y sub p. So that's going to be -6 ax minus 6b. Because I have to multiply -6 times y sub p equals 2x. So a minus 6b equals 0, and -6a equals 2. So a equals -1/3. And b equals -1/18. So a was -1/3, b was -1/18. So that means that y sub p is equal to -1/3 x minus 1/18. So y, the solution, is equal to y sub c plus y sub p, which is equal to c sub 1 e to the -3x plus c sub 2 e to the 2x minus 1/3 x minus 1/18. Let's see if we can do one that has just a little more challenging general y sub p before we go into anything too crazy. Alright. So I'm getting this out of on the same page on 147. Alright, and this is y double prime minus 8y prime plus 20y equals 100x squared minus 26x e to the x. Now, our auxiliary equation is m squared minus 8m plus 20 equals 0. 10 and 2 can give us 8, but you can't multiply 10 and 2 by the same numbers that would give us 8 if negative 8 if you added them together. So what I mean is you could have negative 10 and positive 2, but when you multiply those together, that doesn't give you positive 20. So it's not going to work. So more than likely this is going to be an imaginary or complex conjugate solution. So x equals negative of negative 8 plus or minus the square root of negative 8 squared is 64 minus 4 times a is 1 times c is 20 all over 2 times 1. So that's going to be 8 plus or minus the square root of 64 minus 80. 64 minus 80 is negative 16 all over 2. So that's going to be 8 plus or minus 4i over 2, which is 4 plus or minus 2i. So our alpha is equal to 4 and our beta is equal to 2. So the complementary solution is going to be equal to e to the 4x times what? C sub 1 cosine of 2x plus c sub 2 sine of 2x. So that's our complementary solution. Now we're going to have to work on our particular solution a little bit because you can see it's a combination of a couple of things that are in the table. We have a quadratic here, and then we have an x times e to the x here. So let's go back to our trial particular solution table. So we have this one here from the quadratic, and then we have an x times e to the x. OneNote's restarting, give it a second. Somebody hacked into it, didn't they? Alright, so again we have an x squared, we have a quadratic, and we have an x times e to the x. X times e to the x. That's what this is. Linear times, that's linear times e to the x. That's quadratic. So y sub p is going to have two parts. It's going to have the quadratic part, that was ax squared plus bx plus c. Then it's going to have the linear times e to the x part. Now look at the linear times e to the x part again. This right here. We're not going to start over again with a because we've already used a, b, and c. So this is going to be plus dx plus e times e to whatever. So we have to continue on with our alphabet. Hopefully we know that. So it's plus dx plus e times e to the 1x. So just times e to the x. Okay. So that is the general form. I'll multiply that out. So it's ax squared plus bx plus c plus dx e to the x plus, ooh, look, it's e to the x. They found each other finally. All right. So we need the first derivative and the second derivative. Y sub p prime is going to be 2ax plus b. The derivative of plus c is 0. Now I have to use the product rule here. So I have a constant of d in front, so it's going to be d times first times the derivative of the second plus the second times the derivative of the first, and then plus e to the x. The derivative of e to the x is e to the x. Alright, so I'm going to write out those terms. That's going to be d x e to the x plus d e to the x plus e to the x. And then the second derivative, y sub p double prime, that's going to be equal to 2a. The derivative of plus b is going to be 0. Then again, I have to use the product rule here. So that's plus d times the first times the derivative of the second plus the second times the derivative of the first. It almost looks like a 1 there. That's a d. Alright, so then plus the derivative of this. So that's going to be d e to the x plus the derivative of this. That's going to be e to the x. So let's write that out. We have 2a plus dx e to the x plus d e to the x plus d e to the x plus e to the x. These are like terms. So that's 2a plus dx e to the x plus 2 d e to the x plus e to the x. All right. So now we have y sub p, y sub p prime, and y sub p double prime. So now I need to go back to my original differential equation. Up here, I'm going to plug y sub p prime in here. I'm going to say negative 8 times y sub p prime here. Then I'm going to say 20 times y. All right. Very easy to mess up on this problem. Let's see. Hopefully I won't. All right. So we're going to have y sub p double prime, that's just that, 2a plus dx e to the x plus 2 d e to the x plus e to the x. Then we're going to have a negative 8 times this, which is this. So it's going to be negative 16ax minus 8b minus 8 dx e to the x minus 8 d to the x minus 8 e to the x. Then we're going to have 20 times y sub p. So that's going to be plus 20 ax squared plus 20 bx plus 20 c plus 20 dx e to the x plus 20 e to the x. That is going to be equal to the right side of our differential equation, which was 100x squared minus 26x e to the x. Now we do have some like terms that we can put together. We also want to rearrange these so that I have all the constant terms together, all the x terms together, all the e to the x terms together, all the e to the x terms together, all the x squareds together, which only have one. But I do believe we have some like terms. So let me see if I can kind of highlight those with a different color. So we have a dx e to the x here, and we have a negative 8 dx e to the x here, and we have a positive 20 dx e to the x. So if we put those three together, then that's going to be 13 dx e to the x. Is that right? All right. Now let's see another like term. We have some de to the x terms. There's a 2de to the x. There's a negative 8de to the x. Is that the only two? Yes. So that's going to be minus 6d e to the x. We have some, come on. It's going to have to restart again. We had our de to the x terms that I put together, minus 6d e to the x. We have some e to the x terms. Here's a 1, here's a negative 8, and here's a 20. So what's that going to be? 13 plus 13 e to the x. I think that may be a sign. See if you can finish this problem, and that's what we'll pick up on Thursday. Since my computer is not acting right. Well, we'll finish this problem. We just have to combine like terms and set coefficients equal.